Hi everyone. So today we've got one of our students, Ayushman, who has just completed the course Python 3 Basics. And today you'll be giving a presentation on his project, and you start by demonstrating how his code runs on simulation, and then eventually will connect to the real robot and see how it works on the real robot. So I'll hand over the floor to him so that he can start showing us what he has done and taking us through it. All right, Ayushman, over to you.
Thank you so much. So first of all, let's relaunch this and relaunch the simulation. Then we'll start the code. Okay.
All right, so can you be explaining what you'll be doing in the terminal there,
Uh,
or
it's,
what will be
I'm
happening? Yeah.
just running. I'm running the function that is the obstacle avoidance. So it will run for a given distance. Like I set the distance
Mm-hmm.
for how long it should run. Because in the task we have to create a function that will record the total distance traveled. So I'm considering that as a parameter.
Okay.
So it will run for a given amount of distance.
Mm-hmm.
Like here we can see total distance travel is 1.7 meter. So I set that to as long or as far as I want, and
Mm-hmm.
then after that it reaches that distance, then it will just pause or it will complete its run.
Okay.
Till the distance is not covered, it will keep keep going about the obstacle course,
Mm-hmm.
avoiding obstacles. So this is the obstacle avoidance in action. So every time the obstacle is detected, it will take a step back, like do a little bit of back step, like move backwards a little bit. Then it will scan the left and right,
Mm-hmm.
depending upon which direction it should move. Like here, it saw that this was blocked, but this was clear.
Mm-hmm.
So it assumed that the right side was clear. So it will turn right as long as the object in front of it, like in case this was a wall. So
Okay.
as long as the wall was not out of its bounds, it could move, it would turn, and then it will continue its path. Same thing happened here. The same thing happened here. Uh, so we'll come to that in the coding part also, where the thing happens. Right now we are at 5. I think the distance that I set was 9 meters. So
Okay.
it should complete a whole lap and a bit more than that, I think,
All right.
and
All
then
right.
it will just stop.
Okay.
So I think I should just let it run, and then after the run completes, we will go to the coding part. It's 6 meters, so I think about a whole lap is about to complete, and then it will just stop.
All right. All right. Just to find out, is you as your robot is going through its lab, why did you choose 9 meters specifically? Did you just want to go beyond the
Uh,
program?
no, it's not like that. I wanted to control how long it should do this run, and that seemed like a good parameter. I thought of using the equivalent distance from the starting point and the point it is at right now.
Okay.
Uh, but that seemed like not so much of a good idea. Total distance was much of a better to cover the distance, uh, so I went with that one. Uh, but I can run the program without the parameter too. It can just go on indefinitely without any. So I
Oh,
think
okay.
the
All right. I see.
obstacle, it has reached 9 meters.
Okay, I see.
Total distance covered was 9, so we are stopping the obstacle avoidance right now.
All right. So it was just
Uh,
like um, a stop point of some type, right? Otherwise, it would just keep
yes.
going, trying to avoid obstacles.
Yes, it will
Ah,
just indefinitely go round and round,
mm-hmm.
avoiding the obstacles.
Okay, I see.
So
It's interesting
that
to think about the fact that what would happen if it completes the 9 meters without going through the whole loop, but making obstacle avoidance choices, right?
uh, yeah, I mean, at first I was trying to like complete the whole thing, and then
Mm-hmm.
I just gave a random number and tried to see when it would just complete 1 lap or 2 laps.
Ah, okay, I see.
So 9 seemed like the best number. So
Okay, all right,
I
all right.
think I think we can move on to the coding part.
Yeah, sure. Let's go.
So first of all, the classed one. I think I should go start with the obstacle avoidance because that is the main part of the run. So this is the pseudocode that's actually that pseudo function that is actually running the actual function.
Mm-hmm.
Here we are just defining the limit, as I said, total distance 9, and we are defining if the total distance is less than the distance limit, then we will keep uh, keep running the obstacle avoidance.
Mm-hmm.
Here, the sleep timer I could remove. It could run faster, but it's better to leave it as it is. It's better to see it in the terminal. Without this, the terminal moves so fast that it's unable to read anything.
All right. Okay, I see.
Uh, I could comment it and it will run much faster. Like we saw, it took some time going around the whole thing.
Yes.
So this is the we are calling the object as long as the distance is less. This is just to check if the distance is below
Yes.
the 9 threshold.
Okay.
Then this is the actual obstacle avoider.
Okay.
We are call each time we call the function, we are actually updating the distance so that we can reflect that. And there are simple rules. There are simple if loops. The first one is this one: if the object is there in front of the bot,
Mm-hmm.
and by in front I mean the front index. I'm taking 360.
Mm-hmm.
Then we would run this loop. It would stop. It would move a little bit backwards, and then it will again update the distance, of course. Then
Okay.
it will try to. Then if the object is in front of the bot, then we will try to figure out which direction is clear. Is it left or the right?
Okay, I see.
So
I see.
here I'm checking if the right or the left object, the distance from the left or the right
Okay.
is which one is minimum.
All right.
So in case we have to turn left, it will turn left, and it will move a little forward. But the thing about turning left or right, which I found interesting, was I was trying to just manually try and figure out which how much should I turn, how much should I move forward. But
Okay.
I thought that we can just put a while loop so that every time we turn, we can check back that if the object is clear,
Okay. All
and
right. Yeah, that
we
was
will
good.
we will turn as long as the object is in front of us, and then we will start to move forward.
Mm-hmm.
I think the if and else loop both are similar, just turning left and turning right. But yes, that is the if there is object, and if there is no object, then we'll just keep moving forward and updating the distance as we go along.
Mm-hmm.
So I think there are some functions calls that I did here. The first one is the object update the distance. This was I think I was supposed to make this function much earlier, but as a requirement I had to make it here, so I
All right.
did that after all of that. It was supposed to be with the basic ones.
Okay. So
uh,
the the update distance. Why do you think you had to make it below? Is it because you were you called it?
no,
Uh,
no, I meant I keep everything like IMU functions in one place, and
oh. Okay.
odometer.
Okay.
I meant in that sense that
All
I had
right.
to put it at, maybe in the odometer function.
Organizing the code.
I
I
was
see.
supposed to make that, but when I came to the object avoidance part, I I had to make it. So it's just part of the whole alignment thing.
All right.
I
So this
think.
is the
Yeah.
function that
So
you're saying you use Euclidean distance there.
This is not that function. I think that one would be somewhere here.
All right, all
I
right,
think this is that one. So we will pass four values like the previous, the origin, and the current object, current location.
all right, all right,
This is the equilibrium distance that we could get from that. This is under the odometer functions.
all right, all right. So
Uh,
you would check does in your obstacle avoidance, right? You going in a loop, is that right? Your robot is
yes,
going in a loop,
yes.
right? So if you use Euclidean distance as a metric to keep checking how far you've gone from the beginning of the point, how are you going to deal with the fact that at some point you'll be going back to the beginning?
I think I will just define a threshold value. If I'm within that range of that point, I think I will just stop the robot at that point using the same function, uh, the get the distance.
All right, all right.
Uh,
Okay,
yes, I
let's
tried to. I,
you, you try to do.
yeah, I tried to do that. I think, but I couldn't figure out how I should start the robot from the very beginning, because at the very beginning the threshold will be as same as that one.
Ah, okay, I
So I
see.
tried
There we
to,
go.
yeah, I tried to do some workarounds. Uh, Nothing. I could try to do some workarounds, but I think the update distance function worked better for me.
All right,
So
all right, all right,
I tried to use this function. I tried to use this get function, get distance function, but I kept not actually getting around the loop. I
uh,
wanted to get a loop around and then check. So
okay,
yes.
okay, okay, okay. So go ahead.
Okay, so the get function is also was supposed to define in the odometer only. It's simply just returning the current position using the odometry.
Mm-hmm.
Then I think update distance get position. Yes, this one was interesting one. The direction part. I think I have in the very beginning. I called. I think it's not there. I think there was required as a function to make, so direction, which direction the bot is facing,
Mm-hmm. Mm-hmm.
and
Social
I
orientation.
tried I tried to put this in a dictionary, like this could be the key, and this could be the direction would be the actual element.
Okay, I
I
see.
tried to do that, but I wasn't really good at that. I couldn't make the actual dictionary and call at the same time.
Okay, I see.
I would try that later on, but for now, I think if else loop is what I have right now.
All right, all
It
right,
works. I It is in the very beginning we see which distance is facing.
right. I see.
Uh, there are two functions that I defined here, and both have almost the same functionality.
Mm-hmm.
The first one is the object minimum. This is the one that we use to check which direction we should move. So it checks it checks. It is here the front index, but the index can be anything. Any index that we give, be it zero, be it left or right,
Mm-hmm.
it will give the minimum for that distance. It is simply just getting the scan from the lasers, from the lidar. Then we are simply just getting the get we have the front index, so we will need to subtract like minus 90 and minus plus 30. In the instructions it said that we can get as low as 15 degrees, but this values work better for me,
Mm-hmm.
like
Okay.
bit more and bit less.
All right, all right.
So then we will just trim the whole array of like seven, I think 720 indices
Mm-hmm.
to down to the just those ones that we want to search. Then we will get rid of the infinite values, the which ones we don't want.
Right.
And then this part was a little bit cumbersome, because I kept getting arrays with no values. So it was I didn't know which value to return in that case. So I just returned one in here,
Okay.
because that distance would be greater than the threshold value I'm using anyways.
Right.
I can get more values, but That is for next time,
S-
but that is a different case.
So like one is
Uh,
like your error code, so to say, right? To say it didn't go as planned.
uh, no, not in that sense. It like if the no valid data is there, if all of the values in the range is
Oh, okay.
infinite,
All right. I see. I
so
see.
it should, yeah, it is either very far away or it is just stuck in a corner. That
Oh,
is those are the only two options.
right. Okay.
So
Yeah. It's
the
pretty.
one could be used to check that value
Okay.
or
It's
something.
good choice. Good choice.
Yeah, because this function kept giving me errors because there were places where it would get stuck and it would just give me infinite values and it would just keep returning
Mm-hmm.
infinite values.
Mm-hmm.
So that could not work. The next thing is the just the minimum one. We will just get the minimum from the ranges and we will can not print it. We can just return it. Uh, but for the sake of understanding, put a print statement.
All right. All
Now on to the object minimum was done. So object detection is it works the very same way till here I think. Yes, up until here it works the very same way as the minimum distance finder. In here we are just checking if the threshold value which I took as 4. Uh, in the instructions I think it is given 0.3, but for me I think 0.4 is much more safer of a value.
right. Mm-hmm. Okay.
So using that threshold, we are just printing there is no object or returning a false value, so that the function that calls if there is an object can know if there is an object or there is no object.
Right.
So if we return true, then it will know that there is an object and we need to follow the protocol. And if
Mm-hmm.
there is no object, then it will just continue its path.
Okay. Okay.
Uh, I think those are two done. Uh, then these are just simply the IMU values for acceleration, velocity, and linear velocity, angular velocity, and and for the both of them, linear and angular velocities.
Mm-hmm.
These are the odometry functions. As I mentioned, this is the equilibrium distance. This is the orientation, like it returns the three values at once.
Mm-hmm.
This one also the position XYZ positions. Uh, we don't use the Z position, so in all of the functions I'm just using the first two values.
Mm-hmm.
Um, yeah, these are the functions that are used in uh, the functions that like define the minimum and the maximum.
All right. All right.
Uh,
So what was the choice? Why did you have to add the z coordinates? Is it just because you wanted to make your class more generic, or because you knew you were gonna be
I
inheriting in 2D plane, right?
Yes, but I mean, as the function, I was going about defining the functions, and later on, if I wanted to use something differently, so I could just call it the z value.
Okay, so
Uh,
you wanted to
there is no point in defining another function
class,
for that.
yeah, another type or
Yes.
another class of altogether.
So it was just easy. I can just skip that value and get on with x, y anyways.
All
So
right, in your computations,
huh.
right?
Anywhere I can, anywhere I wanted to get the position, I can just call the function and just use the first two values and uh, just leave out the last value.
Okay, okay, all right.
I
I've got
think these are,
about 12 minutes left now. Can we get it to the real live robot demonstration?
I think, yes.
All right.
So I think I'm ready to run.
Mm-hmm.
Okay, I think it's starting. Okay.
Okay, there we go.
Yeah, like it's turning uh, around and should just it should just keep going. I think. Yeah,
I see.
I
I
think
see.
the for the sleep, uh, like the 1 second sleep between the runs,
Mm-hmm.
it is easier to see the terminal that way. So
Okay.
that's why it is
It's
working
constantly
that slow.
stopping. Yeah, I see.
Yes, I can just turn that. I can comment that part, so it will run faster.
Okay. Yeah, no,
But
it's fine.
it's much more safer, and I can see the terminal much better in this way.
Yeah, for debugging, yeah, it works. It's
Yes,
and
yes.
also for
Because I
demonstration.
kept, yeah, because that infinite values that I was getting
Mm-hmm.
just kept getting stuck in the corner, and I could not see the actual terminal running.
All right, all right. So,
So
I would want you to walk me through how you made it cope with the return value one, right, or infinite, right? But we'll speak about that one later.
okay.
All right, it's close to the beginning now.
Hmm. I think 7.9,
Okay,
8.5.
okay, that's the
Think
distance tracking. I see, I see.
yes. I think about 9 meters it will just stop.
Okay, yeah,
8.6.
it's quite. That was quite good to make
I
it
think
stop
yeah,
that
it
way. Yeah,
stopped.
there we go. I see.
Yes. I think it's very close to the value also, like
Mm.
starting value.
All right. I think that's it, right? I would have to. I have a couple of questions I wanted to ask you, and I think one of the first one was the one that I was that I spoke about just recently. Infinite value, right? So when you're running your
Uh-huh.
code on the real robot, right? When you don't get
Uh-huh.
anything from your laser scan, you dealt it by returning one, right? So within the
Yes,
control
yes.
system of your robot, how did you handle that case? Like when it returns one, what happens? Does the robot stop? What does it do?
No, the robot won't stop. The problem that I ran into that I was explaining earlier
Mm-hmm.
was I wanted to get the minimum value, right?
Mm-hmm. Mm-hmm.
So in any case that I'm getting infinite as a value, it either be the maximum value or it would be just stuck in a corner.
Okay,
That
so
those are the only two conditions.
all right, all right, all right.
So in that case, my safe assumption was to just pass it as one, and as I was using the threshold value 0.4,
Mm-hmm.
so it was by default it would consider one as a greater value, and it would not turn that direction,
I see.
and
Okay.
it will just look for the next set of values or next return statement that will give a better value,
Okay. Okay.
because either of the two sets of values would have to have a meaningful value other than infinity.
Mm-hmm. Mm-hmm. I see.
So yes, that is what.
All right. You also spoke about having challenges with the dictionary. Can you talk us through what those challenges were
Uh,
exactly? Yeah.
no, as in dictionary, I think the function was the distance tracker. Yes.
Yeah, this one.
So in the distance tracker, we have to get the odometry orientation, like which direction to go, why, because the other two directions are kind of useless to us right now in a 2D plane.
Mm-hmm.
So by getting the yaw value, we are essentially getting the direction it is facing.
Mm-hmm.
But in order to get that in a meaningful sense, like north, northeast, northeast, or all of these eight directions,
Mm-hmm.
so we have to like use this formula for that was given in the instructions. And I my first thought process was that I could just use this same formula as a key to the dictionary, and this n would be the element. So every time I have to print the direction, I can just put the dictionary and call the particular key value.
Okay, I see.
But for that, you have to like the first thing that came as an obstacle was I could not get the dictionary to work with these math values. It was working, but I could not get the actual values.
All
It
right.
was
So
always like north pointing
mm-hmm.
for reasons. I don't know what the reason was, but
What
the
if
answer was always north.
okay? What if you had done the computation of your values outside the dictionary? Then you just feed the answers into the dictionary. Um,
I
just
could have tried that,
uh-huh.
but when that did not work for like 2 to 3 trials, I
Okay.
thought that what if I could just call an if and else loop and just put that value in a
Okay.
simple variable.
All right. All
So
right.
that is what I did here. It was easy. I just copy pasted and changes very few values here.
Yeah. Yeah. I see.
But yes, I wanted to take that dictionary approach, but this was. I think I will go back to that later on,
And try.
if
Okay.
possible.
Yeah. Yeah. It's all good. It's good to get other people to also understand this. Like, how did it? How was it difficult to you? It also helps in your thought
Uh,
process later
I
on.
don't.
Yeah.
Matlab, the problem with that dictionary was every value that I was passing it. I mean, I was not passing it. The yaw was getting from the yaw value, and it was passed on to the dictionary.
Mm-hmm.
So I don't know. It was always giving me the north value for some reason,
I see.
even though it tried rotating the uh, bot and see
Manually.
the result again.
Yeah.
Yes.
Okay.
So
All right. Do I have any more questions? Oh, the other one. I think this is the last one. I wanted to ask you. So, we spoke about your robot recognizing that it is at the zero mark, right? And when you wanted to initialize it, and the zero mark was equal to the also the end mark, right? So every time you try to start it,
uh-huh.
it would be difficult. How did you handle that? Just to
Um, I didn't actually start with that. That was after I completed after I got this functions working, because I said as the infinite values kept getting me stuck in a corner.
all right, all right.
So after I got this working, I saw that it was just going around in circles. So I thought of adding just one variable, and that is when I thought of using the Euclidean distance to see if I'm going in circle back to the square, back to the starting position.
Mm-hmm.
And then I got into like, what if I just use the total distance travel? I already have the function for that.
Right.
So that is when I just used this one.
Yeah, yeah, that was quite good. Cause also, I would assume if I remember well, the circuit is probably around 5 meters, right? A complete loop, right? But the thing is, because your
Uh-huh.
distance is already bigger than 5, it's almost like forced to go, uh, it, to go
Be,
beyond that. Or if you had set
uh-huh.
your beginning
Beyond
and
that.
your end as 0, right? Then
Uh-huh.
every time it's at 0, it will not start because it thinks I'm at the goal already, right? But if you
Uh-huh. Yes, that is.
yeah
Yes.
find a way of making it go beyond that 0 mark somehow, then it would realize, no, I'm actually not at the end yet. So it would go a little bit past, but
Yeah.
still it accomplishes the goal, right?
Yeah, I tried using that. I set some like values, like I started using like this distance value. If it is below some threshold value, it will just move ahead.
Yeah,
After it goes beyond that value, it will run another loop where we are actually tracking the Euclidean distance.
yeah, yeah, I see.
Uh, but that seemed like much more cumbersome, and it worked fine. But I wanted to stick with this one. It
Yeah,
was
yeah,
much easier.
yeah, it's quite good. The simpler the better, right?
Simpler the better. Yes.
Yeah. All
So,
right. I think that's it from me, and those are all the questions. I would like to say congratulations to you, Aishman. Your presentation was
thank you
quite
very
good.
much.
So I'll just wrap up our broadcast, and then we can continue speaking on Zoom. Okay.
Okay.
All right. All right, everyone. So that was Ayushman's presentation, and as you have seen, he has managed to accomplish quite a lot using Python 3 and some basics of robotics. So, if you are keen, you are welcome to try one of the courses that we offer certification on. And until next time, keep pushing your ROS learning. Thank you. Bye bye.